methods of cooling a transformer. The first method is called dry type of transformer cooling, and the other one is oil immersed transformer cooling. There are different methods of cooling the transformer. For dry type, we use air natural, air blast, and for oil immersed, we use oil natural, air forced, oil forced, air forced, oil forced, and water forced. So let us see each one of them separately. What is air natural or self-air cooled transformer? In this method, the cooling is generally used especially in a smaller type of transformer up to 3 megavolt ampere. In this method of transformer, natural air is passed such that it cools the transformer windings, whereas in air blast it is used more than 3 megavolt amperes such that cooling is done by natural air method is somewhat inadequate. So air is forced here such that the core and the windings are connected with the help of the fan and the blowers. They are dried and they're cooled. The air supply must be filtered to prevent the accumulation of the dust particles in the ventilation ducts. Remember, this method can be used up to 15 megavolt amperes. After 15 megavolt amperes, I have to go for oil immersed type. In oil immersed, there are 4 types. The first one is called oil natural, air natural. So this is the diagram for oil natural and air natural, where you are going to have in the heat that is generated in the core and the winding are transferred through the or to the oil, and according to the principle of convection, the heated oil flows always in the upward direction and then in the radiator. The vacant places are usually filled up by the cooled oil through the radiator. The heated oil from the heat from the oil will dissipate into the atmosphere, and due to the natural air flow, you have air also which is naturally flowing around it. Therefore, it gives you the cooler feeling. And due to natural convection, the oil that is in the transformer is made to circulate and dissipate the heat in the atmosphere due to natural conduction process also. And this type of method is used up to 30 megavolt ampere. After 30 megavolt ampere, you use oil natural, air forced. So in oil natural, air forced, you are forcing the air into the transformer tank through what we call it as it is done through blowers. The heat dissipation can be improved further by applying forced air onto the dissipating surface. The faster heat dissipation is possible than natural airflow. The fans are mounted near the radiator, and they may also be provided with automatic starting arrangement, which turns on when the temperature increases beyond a kept value. And remember, this method of cooling is used up to 60 megavolt ampere. The next one is oil forced and air forced. In this method, we are forcing both oil as well as the air. In this method, we are using a fan, and external heat exchangers are also used. The oil will be circulated with the help of pump, and you have the oil circulation is forced through a heat exchanger. Then the compressed air is forced onto the heat exchanger, where it gets cooled, and the heat exchanger, which are mounted separately from the transformer tank, they are connected through the pipes such that you can find in the figure that the air, and this is the heat exchanger and this is the transformer tank, and through the pipes we are going to pass the oil into it. And this type of cooling method is provided for higher rating transformer at substations or power station. The last and the final method is under oil immersed is oil forced and water forced. In this method, we are forcing the oil into the heat exchanger such a way that we are going to make sure that the forced water is used to dissipate the heat from the heat exchanger. The oil is forced to flow through the heat exchanger with the help of the pump, where the heat which is dissipated in the water is also made to flow. The heated water is taken away to cool in a separate cooler. And this type of cooling method is used in large transformers having rated of several hundred megavolt amperes. Thank you for watching this video. Thank you everyone.